This is class 11th, chapter number 27, Hyperbola. We are discussing about hyperbola. Hyperbola is a conic section. What is a conic section? When you take a cone and a plane and this plane intersect at different angles to this cone, the figures which are being formed are called as conic sections. For example, ellipse is an conic section, parabola is a conic section. Similarly, hyperbola is also a conic section like this. So this plane, you can see the angle it is forming. If you take the axis, it's parallel to this. So how can we form? Because we know about parabola, so you can just take an analogy that you make two parabolas here, one on either side facing x-axis here, right? This is a hyperbola. There are two definitions of hyperbola. One I'm going to give you right now, that is, if you take any point, that is the set of all the moving points or the locus of the moving point, because this figure you can see they will have two focus. You take any point, so the distance of this moving point or the locus of that point from the distance of this point from two focuses, d1, d2, if you take the difference of these two, it will be a constant. You can take any other point on this parabola, again take the distance from two focuses, take say d3 and d4, and take a subtraction, d3 minus d4, and you always have to take the modulus, because modulus means you are taking the distance, and they will be equal, and it will be equal to a constant. It will be a constant. This is the definition of a hyperbola. There is one more definition that I am going to give you later on when we actually prove this formula. So always remember, it will be a constant, any point, distance from two focuses, the difference of this distance will be a constant. This is what do you mean by hyperbola. Okay. Now let me tell you the formula. We have learned about ellipse. The formula of ellipse was x square by a square plus y square by b square equals 1. If you remember it, it was this a and b was major axis, b was the minor axis, x, y is the locus of that point. So ellipse and hyperbola, most of the formulas are exactly similar. Hyperbola, ellipse, most of the terms, formula, equations are same. Similarity you see here because the ellipse, the formula was having plus here, but in hyperbola it will be negative. That is, x square by a square plus y square by b square, that was in ellipse. Now you can make it as negative. X square by a square minus y square by b square equals 1 is the equation of hyperbola. So if you remember ellipse, we said one ellipse was horizontal ellipse, the major axis on the x-axis. The other one was the vertical ellipse, the major axis on the y-axis. But we'll call it here this as two other terms. We'll not call them as horizontal and vertical, but we have some other term, different term to name them. You can always call them as horizontal and vertical, nobody is going to say anything. But in mathematical terms, the left one, which you see as the horizontal parabola, is transverse. The right one, which is the vertical, is conjugate. Okay. So for the sake of convenience, let us assume that this point is the intersection of the coordinate axis, which is 0, 0. It will not be, because some center points of HK will be there, but for ease of understanding, 0, 0 is the origin. When you are making an ellipse or a parabola, what do? Because you are actually trying to find out the locus of the point. So whenever it is intersecting the x-axis or a y-axis, this figure, is called as a vertex. But for an ellipse and a hyperbola, there will be two vertex. So we will not call them as vertex but vertices. Okay? No, two vertices. From here to here, the distance between the vertex, if the center is origin, it will be A, this side, A, that side. So the vertex equation, or you can say the coordinate, will be plus minus A0. A on right hand side, A is on negative side. Every elliptical or the hyperbolic or parabola will have a focus. So let us say that this figure has two focuses, F1, F2. When we have two focuses, we call them as foci or foci. So now again, if you assume it to be some C distance from the origin on the right hand side and minus C from the origin in the left hand side, so you will call it as plus minus C. But I'll prove it that this C is equal to AE in our later discussion, AE. So by now you can just remember it's AE. Okay. Now I'll go to the, if you take to the y-axis, let me tell you the other things remain same as ellipse. 2b square by A is the latest rectum, right? Various things remains the same. There are different books which show you different formula, but we will try to only take one of the scheme, right? X square by A square minus y square by B square. So here if you see x square by A square, x square and y square has been changed. X square and y square has been changed, and I'll tell you what formula we are going to use for a vertical and a horizontal axis. Let me complete this vertical axis first. It was plus minus A0 on the horizontal. Vertical it will be because it is on the y-axis. So the x-axis will be 0 and y-axis will have plus minus A. This will be the same as vertex as we saw on the transverse one. So the conjugate will have plus minus A as y coordinate. Focus similarly we have, again x will be 0, and similarly what we have taken in the horizontal, which will be plus minus C, but as I said, this C I will prove it to be AA. So as I was telling about the formula, these are the list of transverse and conjugate. The first column is the name. This column, second column, is transverse, horizontal, transverse, horizontal, T I am writing. The third column is conjugate or a vertical hyperbola. Let me just draw it here for ease of understanding. This is a hyperbola, okay, horizontal, and this will be a hyperbola with what? It will be on the vertical axis. Okay, so x square by A square minus y square by B square equals 1. Here what we have done, we kept A square and B square as it is. We kept A square and B square as it is. We never changed it. Right? But the x square y square we have interchanged. What is this I told you? Plus minus A0 for horizontal, 0 plus minus A for the vertical. Foci I told you it will be AE0, 0 AE. Center 0, 0. Transverse axis, what will be this one? 0, A, this is A. So it will be 2A. And I'm going to explain you how it will be 2B, what 2B means. It's always a confusion. So just for time being, just assume that this is the vertical axis distance, 2B. 2A, 2B for the transverse conjugate same. Okay. What about the eccentricity? Eccentricity, it will be under root 1 plus B square by A square. Here we have changed it. For vertical, it will be under root 1 plus A square by B square. A square, B square we have exchanged, right? Directrix, no change. I'll prove it to you that it will be x equals A by E plus minus A by E on the other side, because both will have two directrix will be there. There is a change here. All the tick I am showing is there is no change. They both are similar. There is a parametric coordinate also, a sec theta, b tan theta. For the first one, second one we have b tan theta minus a sec theta. Now let me tell you about this fourth column. In some book, what they have done is x square and y square, y square by b square minus x square by a square they have done, right? So the position of x, a and y and b have changed. So only the thing will be it is vertical axis, so you'll get b, you'll get 2b as the transfer axis, under root a is 1 plus a square b square, foci plus minus be, directrix you have b by e, and the parametric coordinates will be a tan theta, b sec theta, right? So this we are going to discuss, because I am going to actually now in the next discussion I am going to prove this equation. How did this equation has come? Okay, till then, thank you so much. Take care of yourself.